Hello, everyone, and welcome. I'm so glad you joined us. I'm Lindy Elkins-Tanton, Vice President of the ASU Interplanetary Initiative and Principal Investigator of the NASA Psyche mission, which is a robotic spacecraft being sent to investigate a metallic asteroid. I'll be moderating today's Why We Go panel. The Why We Go series puts the science and engineering of space exploration into the context of society, law, policy, biology, all that makes us human. This series is a collaboration between ASU's Interplanetary Initiative and Baylor College of Medicine's Translational Research Institute for Space Health, or TRISH for short. This is the fourth of our 4 starting sessions in the Why We Go series. Our previous 3 sessions, the first on why humans go to space, the second on why going to space is so difficult, and the third on social and legal futures of humanity as an interplanetary species, have been posted on the ASU and TRISH websites, so you can go and watch them in case you missed them. But today, we're going to be discussing Mission Impossible, Terraforming Mars. So we're starting with a little opinion. It may be overcome by conversation. What does terraforming mean anyway? Is it possible to terraform a planet, not the Earth? And even if we can, should we? I am joined today by Dr. Jim Bell, planetary scientist and professor at Arizona State University, and Dr. Jeff Hoffman, an innovation specialist for Trish and professor of aeronautics and astronautics at MIT and a former NASA astronaut. I will give them more detailed introductions shortly. I will guide today's conversation, but please submit your questions using the Zoom Q&A feature. We'll leave time at the end to answer as many as we can, so be sure to put your questions into the Q&A. I see we've got a couple already, which is really amazing. I love it. And ASU's Interplanetary Initiative, a little introduction, we are trying to empower individuals to see themselves as interplanetary and take an active part in creating the space future they want. And we're ensuring broad societal participation in the structures and systems that will shape humanity's space future. Our work includes both degree and non-degree learning programs, research into multiple interdisciplinary directions, and space, hardware, and software build, test, and fly in our dedicated lab space. And my partner in this lecture series is Dr. Dorit Denoviel, who is the executive director of TRISH and an associate professor in pharmacology and chemical biology and the Center of Space Medicine at Baylor College of Medicine. Dr. Denoviel is going to tell you just a little bit about TRISH. Go ahead, Dorit.
Thanks, Lindy. This is such a pleasure to do this with you. It's been so much fun. TRISH is a virtual institute based at Baylor College of Medicine with consortium partners Caltech and MIT. We are funded and partnered with the Human Research Program at NASA's Johnson Space Center. Our mission is to find, fund, and implement new ways of reducing the risks to human health and performance of astronauts exploring deep space. So we are actually a grant-making organization. We fund research throughout the United States, both in universities and companies, in all kinds of areas. We touch behavior health solutions, medical capabilities, food, radiation protectants, et cetera, et cetera, et cetera. And we also have some educational opportunities as well. So please check our website, and I look forward to today's discussion. Thank you.
Thanks so much. All right, so for the conversation today, I'm joined by Dr. Jeffrey Hoffman, who's an aeronautics and astronautics professor at MIT and an innovation specialist with TRISH. He's an investigator for NASA's MOXIE instrument on the Mars Perseverance rover. This is a project dedicated to demonstrating how future explorers might extract oxygen from the Mars atmosphere. And Jeff, you may not realize that Jim and I are tied to you because we were both on the science definition team and were supportive of adding the MOXIE instrument to the Perseverance rover back when it was just an idea in our heads.
Thank you very much.
Oh yeah, Dr. Hoffman is a former astronaut, and he's logged more than 1,200 hours and 21.5 million miles in space. He made 5 flights, including a first shuttle mission to repair the Hubble telescope and the 1990 Space Lab shuttle mission. So a lot to say about terraforming on Mars. Now, Dr. Jim Bell is a planetary scientist and professor at Arizona State University's School of Earth and Space Exploration. He's worked on planetary exploration missions to almost all the targets you could think of, including on Mars, the rovers Spirit, Opportunity, Curiosity, and Perseverance, for which he leads the Mastcam Z camera, the one that brought us the imagery of the helicopter flights, and I believe the picture that's right behind him right now, and will go on to push the horizons of science. He's also the deputy principal investigator and imager lead for the Psyche mission. And he's past president and sits on the board of the Planetary Society and has written several excellent popular science and space photography books and books about missions. And so I'm now going to invite our speakers to introduce themselves and to begin the conversation by answering the starter question, how do you define terraforming? So we're going to start with Jeff. Jeff, can you start us off with a little bit on what you're working on right now and how you would define terraforming?
Okay, as you mentioned, MOXIE is the very first time that we are doing an experiment which will use extraterrestrial resources to produce things that will be of value to eventually to a human mission. Obviously, it's a demonstration producing oxygen. We don't have anybody there to breathe the oxygen, but someday. And of course, you need oxygen not just to breathe, but assuming that you want to come back from Mars, you're going to need a pretty big rocket to get off the surface. And that actually takes a lot more oxygen than you need to breathe. And so MOXIE is basically NASA requires that if you're ever going to use a piece of hardware or a process that is mission critical, you need to demonstrate it in the actual environment. And obviously, making the oxygen that will get you back from Mars to the Earth, I would consider mission critical. And so, although the technology of MOXIE has been tested many times in Mars-like conditions here on Earth in laboratories, we need to show that Mars doesn't have any nasty surprises. And so far, so good. Having said that, as far as a definition of terraforming, let me just briefly share my screen and here we go. This is a picture of what we think Mars might have looked like. Oh no, that's not what I wanted. This is what I want. Let me, there's quite a bit of, all of the previous rovers that Jim has worked on have indicated that we believe that Mars in the first billion years or so of the history of our solar system was very different from what it was like today. We believe it had liquid water on the surface, possibly an ocean covering the northern hemisphere. There's indications even of a shoreline, and that means it had an atmosphere very much similar to the conditions we have here on Earth at the time. And that's basically when we use the word terraforming, I mean, terra is Earth. So what it means to me is, could we transform Mars from the cold, dry desert that it is today into a planet that would be more Earth-like, capable of supporting terrestrial type life? And so that's my take on terraforming, and I'll stop sharing.
Fantastic. I love that image of what Mars might have looked like in the past. I think we could probably spend an hour arguing about that by itself. I
just say there's some indications that it might have been like that. And
totally with you. There's a lot of science to talk about there. So Jim, tell us about what you're working on right now and how would you define terraforming?
Yeah, so first of all, thanks for the invitation to participate in this. It's going to be fun. Big fan of Jeff's work in space and on Mars. So my work on Mars is, obviously rovers and orbiters and basically, getting an assessment of the current conditions. We're there in the Mars climate and environment of today, making direct measurements with cameras and meteorology instruments and spectrometers and all that. And so, any discussion about changing the environment of any planet has got to start with a survey, a census of what is there. What are the raw, products that are available, the resources available to potentially make a change using resources in place, so-called in situ resources, or what might need to be brought in from outside, from the Earth or other planets. So a lot of what we're doing, Perseverance and Curiosity and rovers before them, is just characterizing the current environment. The same with the orbiters. How much water is there? How much can we detect? How much CO2 is in the atmosphere? How much might be buried in the subsurface? How much might be stored in mineral deposits? How much water? How much other volatiles, et cetera, et cetera. So that's kind of what I think a lot of us in NASA and ESA and other space agencies are doing right now, is doing that basic inventory. What is there? And we're doing that all across the solar system, of course. To me, I basically agree with Jeff's definition of terraforming. It is, changing the fundamental environment and climate of a planet to be more suitable for life as we know it. You could argue that, a lesser amount of terraforming might be required for hardy, extremophile, single-celled organisms to survive in an environment like Mars. And in fact, there's even arguments that there are such organisms potentially on Mars today in the subsurface.
Would be great. Yeah.
We can't say that that's not the case. But I think mostly what we're talking about is for us, is for our descendants, for settlers of the future who are going to try to live on Mars and try to turn it into a place. Terraforming is trying to turn it into a place that is much more familiar to us than Mars is today. I mean, it kind of looks hospitable. Oh yeah, that's like driving outside of Amboy, in Southern California, whatever, right? But the reality is incredibly harsh. 1% of the surface pressure, temperatures that only occasionally get above the freezing point of water, no breathable oxygen, despite Jeff's best efforts in the atmosphere for us, CO2 rich atmosphere, no ozone layer, so ultraviolet light bathing the surface continuously, cosmic radiation bathing the surface because the atmosphere is so thin, nothing to eat, nothing easily accessible to drink, and you need energy to convert the ice to water, nothing to do. It's a pretty damn harsh place. And so getting that place, which is not really familiar to us compared to the Earth,
Right.
to be like the Earth, that is going to be a big, big, heavy lift.
Big, heavy lift. So agree. And we have so many great questions in our Q&A. So I want to go through just a couple more questions that we had prepared, and then we're going to turn to Q&A and let you guys just rip in the Wild West and answer everything that's coming in. So Jeff, with your experience in human spaceflight, what do you think are the most neglected critical aspects of getting human to Mars and allowing us to settle there for some period of time? I'm guessing you're going to start with, we have to be able to produce oxygen. But what do you think's been neglected? What are the really hard ones? What are the heavy lifts there?
Well, I don't think it's that anything has been neglected, but I mean, there are some problems that people have been working on, and how to survive the radiation environment. The estimates are that for a 3-year trip to Mars, you would pull in more than one sievert of radiation, which is already above NASA's lifetime limit. So that, that's one major thing. And the other thing is, getting resources. For instance, we talk about being able to mine ice on Mars and get water out of it. As Jim says, first of all, that would take a lot of energy. I mean, it's more than just energy. You need to set up a mining operation, roughneck astronauts to, handle the drilling. And plus the water that we know about now it tends to be at higher latitudes than we tend to go to. And, that's one nice thing about pulling oxygen out of the atmosphere. It doesn't matter where you are, the atmosphere is always there. But water, you got to go to where the water is. And then the reliability of your systems. Once you fire your engines for the trans-Martian injection burn, you're on your own. And
Yes.
if something breaks and you don't have a spare part, maybe you can 3D print it, but basically you are on your own. So the degree of autonomy and self-reliance is going to be far greater than anything we've done so far, because it's a long mission. Obviously they were on their own when they were on the moon, but it was only a couple of days away and they came right back. And on the space station, if something breaks, we can send up a spare part, not when you're going to Mars. So, that's just a short list, but it goes on, but I'll stop with that.
Yeah, I think that we're going to get back onto some of this. And by the way, if there's ever a moment where, for example, Jim, if you want to add directly onto that question rather than having me go on to the next one, feel free to jump in. But in the meantime, I want to ask you something that's really about planetary science, since there you are in your wheelhouse. So Mars has got what, like 38% of Earth's gravity. So right away, we're going to have a gravitational issue in retaining a thick atmosphere. Maybe you can say some more about what you think are the biggest Mars physical and chemical barriers to human habitation, to terraforming.
They're pretty enormous. And we're obviously not going to change the gravity of the planet. And so what that means is that, we as a species are going to eventually adapt to that gravity. Certainly first people who go there, maybe planning a round trip, there are things that Jeff is very familiar with that you can do to work out and, lift weights and do the treadmills, keep yourself as tuned to the gravity you were born in as possible. And that can still be done on Mars. But can you imagine Martian actual settlers trying to keep up with Earth gravity for generations? No, of course not. It's we are going to evolve. The Martian, we will be the Martians, and they will be different than Earthlings. So but in the short term, that's a challenge. Another big challenge, Jeff mentioned the radiation. That's a big challenge, solvable, but a big challenge. The dust is a huge challenge as well. You probably people remember those pictures of the Apollo astronauts on the moon and how filthy their spacesuits got because of the fine grain component of the dust. And Mars has very fine grained dust. It's like smoke, micron sized particles. It's going to be all over the spacesuits. It's going to be all over every, joint. It's going to be all over the airlock. They're going to be breathing it.
And it's got, we believe it's got some perchlorates in it, which
there could very well be health issues.
Can you just talk a little bit about perchlorates for people who may not be up on the issues of perchlorates?
I'm going to defer to Jim on that.
Okay.
Go, Jim.
I know they're there, but I'm not a chemist.
They're there and they're bad. Tell us about them.
I'm not a chemist either. They're there. They're bad atmospheric chemistry.
I mean, they mess up your liver, right? You get too many perchlorates, and you're gonna. Mark Watney, he was eating those potatoes that in the Mars dirt. I don't know what happened to his liver after he got back to Earth, but it probably was not good.
Yeah. Anyway, so it's just a great example of potential oxidants and superoxidants in the soil that not only could be health problems, they could erode tires or other systems, etching them, et cetera. There's been lots of work at discovering very acidic materials, sulfates and other acidic materials in certain parts of Mars. So there's no end to the harshness. We think about the first settlers moving west across North America, or one can imagine the first settlers moving across Africa, and they had challenges, but when they got to where they were going, there was oxygen, there was probably water in the streams, there were fish there to eat,
and there were nutrients.
None of those things are waiting for us.
So they could grow food.
Nutrients.
Exactly. So, it is going to be, and I'm maybe sounding pessimistic, but I'm an optimist. I think it's going to happen. I think people will go within the next few decades. It could be NASA, it could be Chinese, it could be SpaceX employees, who knows, right? But I think that people will be going to Mars in the near term decades ahead, and we'll be settling for the long term. But I think, and I'm sure we'll come back to this, Lindy, but when we talk about terraforming, it's long term.
Long term.
Yeah,
thousands of years.
Terraforming, you're talking about the entire planet. When we initially go, we're going to, we clearly have to have small Earth-like environments, but they'll just be in our habitation.
That's right.
Modules, and eventually we'll make them a little bigger, maybe big inflatables. And so we will try to create Earth-like survivable environments, but on a very limited scale, nothing planet-wide for sure.
Something that a scaled up MOXIE can help us achieve in the short term while we think about what's happening to the planet.
Well, it's
in the movie, the Martian movie didn't really refer to this, but in the book, Andy Weir referred to the device that was making the oxygen. He called it the oxygenator. And we like to think of that as being the great-great-grandchild of MOXIE.
Perfect. That's exactly what it is. What were you going to say, Jim?
I was going to say, what I really meant to say was thousands of years, if ever, because, when we get back to those resources that we would need, right? A number of folks, including our colleagues, Bruce Jakosky and Chris Edwards, who Lindy, they've done some calculations. They wrote a paper a few years ago in Nature. Is there enough CO2, accessible water, to pull out of Mars to thicken the atmosphere? And their conclusion is no.
Right.
The polar caps are very small. The inventory of water, while we don't know it exactly in terms of subsurface ice, is, it's a small planet. The magnitude of how much you would have to pump into the atmosphere to create global warming, which of course we're doing on the Earth, so we have some experience with that. The magnitude of that is perhaps beyond the resources that are available. So you're talking about bringing stuff in or creating, on a massive scale, creating an environment and an amount of CO2 or other CFCs or other gases, water that will increase the temperature through greenhouse effect that we can't do right now. Our technology is not there.
Our technology isn't there. And also, as you say, the resources on the planet itself are insufficient. And then if you take into consideration the low gravity and the fact that there's no shielding magnetic field, we're going to have the technology to continue supplying Mars periodically with externally obtained volatiles for its atmosphere. There's a very good question in the Q&A here right now about where are we going to get the nitrogen? Where's our neutral gas that will be able to breathe what we result in getting? And I think there's going to have to be a kind of a comet treadmill, almost bringing in that kind of material, which we have no precedent. We have no technology for this. So just keeping that in mind for a moment, I want to turn the conversation for just a little bit, and then we'll go back to the technology aspect, to ethics, because this is a question that comes up an awful lot in these conversations. And I'm looking at it from several different points of view. And Jeff, I'm eager for you to take any one that you like or a different one. One of the questions we get all the time, and it's in the QA and already, if there is life on Mars, first of all, from my point of view, it's most likely microbial and under the surface where we can't see it right now. What are the ethics of our coming and adding our microbes, which we already have done a little bit. Another question is, should we be thinking about terraforming another planet when we're having trouble keeping our planet terraformed? And then there are questions, for example, of societal equity. Can we govern ourselves? Can we include all the people on Earth if we're thinking about going to Mars? What do you think about these ethics questions?
I think both of us have definitive answers. Both of us have definitive answers.
Okay, so I'm really glad, because that would just solve a lot of problems. So Jeff, go for it. Let's nail this one.
I look, one of the things that you sense as an astronaut in space, I look out the window or the other side of my space helmet and realize almost all of the universe is incredibly hostile to life. Life is special. Right now, we only have one example of it here on Earth. If there is no life on Mars, I think it is an ethical good. It is a positive good to spread life to a new environment. If we find that there is life on Mars, first of all, it's incredibly important that we understand it, because all of our, I mean, physics, chemistry, our spectroscopy and telescopes tell us are pretty much the same all over the universe. But biology, fundamental laws of biology, we only have one example. How could you have a universal theory of linguistics if you only spoke one language? So if there is another form of life on Mars, that's incredibly important to preserve it and study it. But we're going to have to go there in order to study it properly. And people are talking about establishing reserves, keep people in a limited area so that we don't mess things up. On the other hand, if Mars turns out that we don't find any life, as I say, expanding life to a new habitat, I think is a positive ethical, I don't want to say imperative, but it's an ethical positive.
Very interesting. What do you think, Jim?
I think it's a great set of questions, and it's really important to think about these things, not just in the science fiction, prime directive sense, but in the real sense. I mean, we are already doing things to other planetary environments that could be contaminating them for whatever is there, or at least contaminating our ability to truly assess the origin of any potential life elsewhere out there. So these are great questions to think about. I think that the practical assessment of such questions is probably in the far future, but that doesn't mean we shouldn't think about the implications of what we're doing. We're the second species on this planet to be changing the climate of this planet, right? And the first species, of course, the blue-green algae, some 2+ billion years ago, poisoned everybody else with injecting all this oxygen into the atmosphere. We are a result of that. Was that ethically bad of the blue-green algae? Good question. They didn't have the choice like we do. But and for me, a lot of it goes back to, and you've probably covered this already in other webinars. Why do we explore? Why do we go out there? Why do we go to places like Mars? And almost every day I'm reminded it's so we can understand our own planet better, and our own climate, our own environment, what we're doing to our climate and our environment as a species. And so I'll throw my optimism out there. If we get to the point where we have the technology, which we don't have right now, to really seriously talk about changing the climate of a planet like Mars to be much more Earth-like, if we get to that point, I can't help but believe that we will have solved or be able to solve so many of our sustainability and resource problems right here on this planet,
So important.
using that same technology. So I'm a big believer in that aspect of trickle down of planetary exploration. We've already seen over the past decades a number of examples of how we've learned about our own planet by studying others, and I think that's just going to continue into the future.
I think a lot depends on the amount of energy that is accessible to humanity. I mean, when you look at the history of humanity, every time we've developed a fundamental new source of energy, it's changed civilization, it's changed what we're capable of doing, whether it's fire, agriculture, steam, and so on. And, given the fact that physics now with dark matter, dark energy, and we've realized that we only know what about 4% of the universe is made of. I can't help but believe there's going to be discoveries in the future in physics that will fundamentally increase the amount of energy that humanity has at its disposal. You give me enough energy and I'll terraform anything you want me to.
That's right.
But when that's going to happen, I have no clue.
Yeah, and that ties in, that nuclear is on your list, right? And we're already talking about, maybe we need nuclear propulsion, nuclear electric to even do our first forays to Mars.
Nuclear thermal, whatever.
Yeah,
Plus,
and so there's obviously a whole other range of ethics associated with
how are you
nukes and space issue.
how are you going to have a sustainable source of power on Mars when you have a day-night cycle and dust storms and
Yes.
and the solar energy reaching Mars is only half what we have here on Earth. So I'd rather we develop fusion and have a nice clean fusion reactor, but we haven't quite got there yet, but someday.
So I'm saying that we have a kind of a timeline starting with MOXIE and Perseverance, and we're going to make some kind of small settlement with a bubble, and simultaneously we need to develop fusion. Then eventually we're going to have to figure out how to tow things in, asteroids and comets that have enough volatiles to keep us going. So this is a very long-term process.
Maybe recreate a magnetic field around Mars, which again, I mean, that's so far out of anything that we can imagine with our technology, but again, give me enough energy and I'll create a magnetic field around Mars. So, how long?
Jeff Hoffman, geophysics god.
I know.
Awesome.
I know. We other geophysicists feel a little skeptical about that one, but I'm willing to believe you. I think you got this. So let's talk about who's going to go. Jeff, how do we decide who goes? You're going to go. Excellent. Okay. So before you answer, I just have to tell you, I've been doing polls on social media about this, and about 20% of the people who talk to me on Twitter would say they would go today, even if it was a one-way trip. So talk to me about going to Mars, Jeff. Who's going to go?
Well, right now, if you really want to go just on a one-way trip, I'm not sure I would want to go with you as a traveling partner. But if we have the capability of, because I don't think right now we have the capability for long-term survival on Mars. That's right. What I'm saying. It would be a suicide mission, and that doesn't really appeal to me. That will change in time, and right now, who should go? Yes, we clearly want to have scientists there, but it's clear that for proper exploration, we need to develop the ability to drill and to drill.
Oh.
So you remember Armageddon, the whole business. I mean, maybe we need some roughnecks in spacesuits who know how to operate drilling equipment.
Yes.
Just like on the space station and space travel in general, the types of backgrounds of astronauts has expanded tremendously over the original test pilots, and going to a new environment, there's going to be a whole new set of requirements of what kind of skills that we need. Geologists for sure,
yes.
biologists, but also the people who can operate the machinery and repair it and keep it working, and all the infrastructure that you're going to need to support human exploration and eventually a human settlement on Mars.
We need every kind of person if we're going to become interplanetary. And I knew we were going to come to Bruce Willis eventually because he is the answer to this. But I'm thinking about even another context beyond that. And maybe Jim, you would like to weigh in on this. In the Q&A is a very good reference to the Outer Space Treaty. Outer space is not subject to national appropriation by claim of sovereignty, by means of use or occupation, or by any other means. And one of our challenges as humanity is to do exploration off planet better than we did it on planet. So how do we include everybody? How do we decide who goes, Jim? I know you know the answer.
I totally know. I mean, I've imagined and written about a future where space tourism becomes a viable business model, starting in Earth orbit and extending to the moon and beyond. I do think tourism is a potential valid model for business in space. And in that model, we need all the infrastructure that Jeff talked about, the hotels, the restaurants, the bars, the dance clubs, and artists have to go, and waiters and waitresses have to go, and lawyers have to go, and cops are going to have to go. Yeah, absolutely. That's
space lawyers are good.
Change so dramatically as a species in 100 years or 200. That's all coming. So my answer is who can go? Anybody who wants to would be my dream. Anybody who wants to go into space, at least as a tourist. And like Jeff, I don't want to go on a one-way trip. I would love to go. I want to come back. Earth is my favorite planet, right? I've lived here most of my life. Most of my friends are from here. So I definitely want to come back. I think, as we start, as more of this commercial space and government access becomes more routine, and I use routine in quotes because it's never going to be routine, right? It's a controlled explosion. Even just airline travel, it's hard to believe it's as routine as it is.
It is, I agree.
But I think that future is coming, and I believe that along with the tourists, which means anybody can go. I mean, it's not going to, hopefully it'll be affordable to the middle class, like airline travel is today. Maybe we'll get to that point, but also there's going to be scientists, researchers, miners, engineers that are going to be out there doing the exploration and crawling all over the planet, like geologists and biologists crawl all over our planet.
Right.
And probably interfacing with the tourists, that kind of ecotourism kind of model. I think that'll work great on Mars and Europa and anywhere else you want to send people out there. So I would love to see this infrastructure that Jeff was talking about really start to build. And in order for that to happen, it has to be able to make money, right? NASA's not going to do that. ESA's not going to do that. It has to be a business model.
There has to be a business case.
Seeing it happen in Earth orbit, right? It happened with communication satellites, huge business model, lots of money to be made. Starting to see especially this past week, right, with Virgin and Blue, both sending 8 new astronauts out into space just above the Kármán line. And this is just the beginning, the nascent start of what is going to bubble into some, the economy of near Earth space is going to be an important part of the global economy, and that could just keep going.
And eventually extending out to the moon.
And beyond.
The moon will be the next place to bring into the Earth's economy, as GEO is now.
That's right. There's this question that we're all facing, and Jim is offering an answer to. How do we have a business case outside of Earth orbit when the anchor tenant, NASA or ESA, is no longer there? Like that's the challenge for the future.
Or if they're there, but they just can't afford to throw, make it a money pit, right? It has to return something to the taxpayers or whatever.
Yes.
Right. It has to be some, NASA expends all of our money on our behalf, and ESA does for European taxpayers, to get, to rewrite the textbooks, to make scientific discoveries, to push the frontier of exploration. None of that makes any money,
No.
And so it costs a lot of money to do infrastructure, which is why the business world has to come into it at some point.
Mars is literally a planet-sized money pit. That's what we're talking about. Yeah.
Sort of.
So, all right, I've got one more ethics question before we jump back into the tech, and I want to ask you then also about timelines. I'm wondering, Jeff, and then Jim, Jeff, if you'd be willing to go out on a limb and tell me what you think the chances are that there is extant life on Mars today.
If you're asking for a probabilistic number, I don't have a clue. All we know is that it appears that in the early history of the solar system, Mars was quite similar to the early Earth. And what we do know about the early Earth is that almost as soon as conditions became amenable for the development of life, life developed.
Right.
Whether that happened on Mars, that's what we hope to find out if we bring some of these samples back and look at them. But that's about as far as I can go.
Are you worried about finding life on Mars? Fossil life is one thing, but actually, like,
I think that would be one of the most exciting discoveries that we will have made.
I'm totally with you.
At all.
Yeah.
What worries me is, after Viking went and didn't find life, and then people sort of lost interest in Mars for 30 years. If people say, well, we didn't find life, so let's forget about Mars, that would be a shame. That's the only worry. I mean, Mars is interesting for many other reasons, but certainly the possibility of life on Mars is what I think gets a lot of people's excitement and attention.
What do you think, Jim?
Yeah, I mean, like Jeff, I don't know a quantitative answer to your number, what is the probability of life on Mars. But what I do know is it's not zero.
Yeah.
It is not zero, right? It is a non-zero number, maybe small, but it's not zero. We've learned so much about the place and about our own place, about the origin of life on the Earth, which we still haven't solved, but the environments that were there on our planet. I kind of disagree with you. I don't think Mars was ever very much like the Earth. I think it was warmer and wetter, but I think it's always been a cold and pretty dry place, personally. But that, there's a lot of debate. There's no consensus on whether there was a global ocean or just seas and lakes. Certainly liquid water on the surface, so the conditions must have been more Earth-like. But for how long, and was all that water under glaciers? Huge debates. We don't know the answers to these questions. That's why we're exploring. Probably be decades before we figure it out. Probably have to go and figure it out.
Yeah.
Bring these samples back from Perseverance, and then go eventually and figure that out. But we know enough. We know enough about the extreme environments that life exists on Earth, going all way back to the beginning. The diversity of the archaea, the bacteria. We know enough about that to say to ourselves, we can imagine if a certain thermal gradient, a certain amount of subsurface water, available energy, nutrients, chemical energy, or organic energy, there could very well be life down there. That is really exciting because there's not many places in the solar system we can say that, right?
Yeah.
Handful of places in the entire solar system. Mars is the easiest one to get to of all of those.
That's
May
right.
or may not be have the most potential. That might be Europa or somewhere else, for example. But it's the easiest one to get to, which is why we're approaching 50 missions to Mars over the history.
It's incredible, isn't it?
Mars
50.
exploration, which is
50.
why we've had 10 successful landers and rovers on the surface in the history of space exploration. This is why we focus on this place, because it's not zero, and that's exciting.
Absolutely.
It's important for people to remember. I think it's fair to say that every place on Earth where we have found liquid water, some form of life exists there. And even if it's a kilometer underground where the bacteria have learned to metabolize rock, if those bacteria were a kilometer under the surface of Mars, they wouldn't know that Mars has turned into a dry, cold desert. They'd be fat, dumb, and happy, just like they are here on Earth. So
Yes. I want to put in a plug to all the engineers and inventors out there. We really need better ways to drill on other planets. Drilling is so central to everything we want to do, and we're not good at it yet. Let's turn a little bit to food sources. Jim, can you first of all, I've heard you give a really great commentary on the Martian. What parts are realistic and not, just a couple of words. And what do you think about growing food on Mars? Is that something we're going to be doing?
Yeah, no. So, I mean, I love that movie and the book, and I think to me the movie comes as close as I've seen yet to maybe what it might actually really be like for those first crews to go. The dust storm in the beginning is crazy, exaggerated, but anywhere needed a nature versus humans element, and that provided it. Maybe an impact might be more accurate of a threat, but we don't know what that is, right? We know what a windstorm is, right? So
yeah.
It's a great literary device that he used for that story. The reality is, the big Mars dust storm would be like somebody throwing feathers on you, it would just be so gentle. But food, that's going to be a major issue. Somebody mentioned nitrogen, and we need nitrates for fertilizers for plants that we are going to consume, the base of the food chain. Proteins, we need organic molecules. In the near term, all of this is going to have to come from Earth or the lunar outpost if they're cranking it out from Earth, whatever. And it's a challenge. It's a challenge. I mean, Jeff has personally had NASA space food, and could you live on that stuff for 3 years on a round trip journey? I don't know if I'd want to, but yeah. So huge challenge here, but it really fundamentally will come down to will that soil be fertilizable? Will it support plants, the plants that we would bring the seeds from Earth to plant into that soil? And we don't know. It's part of the reason, one of the many reasons why we have to bring some of these samples back. One of the samples that Perseverance is going to take will be one or more regolith samples, scooping up some of that soil and dust, putting it in one of those little sample tubes, sealing it up, putting it on the surface for a future mission to bring back. And an enormous amount of laboratory study will go on, looking at the potential ability of that soil to be fertilized and not be toxic because of perchlorates or other antioxidants or other chemical elements, not be toxic to plants.
What do you think, Jeff? What do you think about food and the problems of the soil? And can we survive on NASA astronaut food for all of that time?
Well, there have been lots of studies of Mars greenhouses. We may not even have to use the Mars soil. I mean, there's hydroponic ways of growing food, but I would suspect
I've been taking bits and pieces from our many questions there. Can we make the transport time to Mars quicker? What do we need in terms of propulsion, rockets, shuttles? What do we need?
Absolutely, it can be done. I mean, we have pushed the limit of chemical propulsion pretty much as far as it can go. Hydrogen, oxygen that's the most energy you can get out of the chemical propulsion. But just nuclear thermal, you get twice the specific impulse, which means for a given amount of propellant, you get a lot more oomph. And so you can get there faster. And that will help solve a lot of problems. Faster you get there, the less radiation you have to deal with. And then there's people working on plasma propulsion. Again, we have to wait few years because it takes a tremendous amount of electrical power, but they're talking about trips just several months to get to Mars if you have enough power to use. So someday will be.
Propulsion technology will continue to advance, probably in unpredictable ways, with nuclear almost certainly playing an important role in future propulsion. So once you embark, the travel time can be shorter. I don't know if we'll ever get to the point, the science fiction point of saying, anytime I want to go to Mars, I'm going to get there fast. Right now, you have to wait for the planets to line up.
Yeah.
Do the Hoffman transfer.
Right.
And it's that's not harder. The energy involved is highly nonlinear when you're not in that optimal wait for the planets to line up. So faster in your term, decades ahead, but maybe still not be able to decide when.
Yeah, that's important because we get used to thinking about how we could go to the moon anytime because it's literally orbit around the Earth. Right. But Mars, of course, can sometimes be on the other side of the sun. It's an important thing just to keep in mind. And we might need better propulsion. And so, Jeff, give me your guess about, or your thoughts about the timeline. When are we going to have assets on Mars? What will the first assets be, and when do you think they're going to be there?
I wouldn't be surprised if the first humans get to Mars sometime in the next decade or the next 2 decades. We're not talking about huge settlements or anything. I'm talking about expeditionary scientific missions. They'll go there and then they'll explore and they'll come back. What it's going to take to go beyond that is going to depend, first of all, a lot on what we discover in terms of the resources. The more we can do using resources on Mars, the quicker we can develop infrastructure there. As far as getting large numbers of people, I mean, Elon Musk seems to think that it can be done relatively soon with his Starship, 100 people to Mars. And he says he wants to bring the cost to the point where it's about what you would pay for a house. So, hey, you want to go to Mars, sell your house, go to Mars and spend the rest of your life there. I don't know. But the technology right now, it's still pretty much brute force. We have the technology that will, after we've gone to the moon again and sort of learned how to, once again, how to live on another planet, I think we'll be ready to go to Mars. It will take a long time. Only a few people will do it, but I think, and that's about as far as I can predict.
What do you think, Jim? What are the first human assets going to be, and when do you think they're going to get there?
Yeah, I agree with Jeff. When I was growing up in the night, we're seeing Musk is a great example, right? And just like we saw the railroads 2 centuries ago being pushed forward by visionary entrepreneurs, like we saw the airline industry a century ago being pushed forward by visionary entrepreneurs, we're seeing exactly the same thing happen in space. And just like back then with the airlines, with the railroads, with the telegraphs, with the internet, government is stepping in. Government is stepping in to provide some funding to reduce risk, to reduce business risk, to reduce technical risk. We're seeing that happen, okay? And so I think, and I said earlier, I don't know whether it's going to be NASA or SpaceX or China, but within the next few decades, I firmly believe there will be expeditionary crews sent to Mars and back, and that'll be spectacular for science, just like Apollo was, right? They were just, one shot, plant the flag, but now we understand the Earth-Moon system so much better, right? Than before we had those samples. The same revolution scientifically will happen for Mars. And then looking more broadly, when can anyone go? When will the cities and all that? I've written about this, and I think it's a couple 100 years. I think, give or take a couple 100 years, things will either be in a heap of trouble here on our own planet in a totally different situation.
Yes.
Or we'll figure that out and we'll move on. And I'm an optimist, and I really believe that is the future coming, is the ability to not just to Mars, but to be all over the solar system in the centuries ahead.
I would argue that in terms of properly re-terraforming our Earth, which we need to be doing imminently, we do have the technology to do that. We just need the human agreement and the determination. But do we agree, based on our conversations here, that terraforming Mars would be possible, but that we literally do not have the technology to do it yet? Is that right, Jeff?
As I said before, give me enough energy and I'll terraform anything you want.
Well, that's a technology question too.
I think that's a yes from Jeff Hoffman.
Yeah.
I mean, look, if you comments have a crash on the surface of Mars, you get lots of resources. I mean, I'm not sure we want to do that, but there's a lot of resources out there in the solar system, and right now, the ability to use them is almost beyond even what we can imagine.
Right.
Somebody
to prove there is no life on Mars. We could easily show that there is life on Mars, some rover discovery or sample that there is, but I don't think we'll ever prove there isn't.
Exactly right.
So if if the idea is, if there's life on Mars, we shouldn't mess with it, we shouldn't go, then it's really either or. We just don't go. Let's never go. That might be the ethically pure solution. Otherwise, if we go, it has to be with the knowledge that we could very well be contaminating biota that is, indigenous to that planet.
It's true. Although we have, yeah, go ahead, Jeff.
Yes.
We did pretty much conclude that the moon does not have life, and that's no longer something.
Totally different situation, right?
Yes.
Very different planetary environment.
If in any of the environments that humans go to on Mars, we'll look around those environments, and if we don't find life, it certainly is true. The absence of evidence is never the evidence of absence. That's standard scientific knowledge. So yeah, you can never definitively prove that something does not exist, because all it takes is one discovery tomorrow, and
That's it. The answer is always going to be either yes or we don't know yet. But I would just point out that despite all of our efforts at planetary protection, we have already delivered Earth microbes to Mars.
Sure.
And so there is that.
when humans go, it'll be a whole new ball game as well.
There'll be a lot more. Yeah, the
But
microbe load will be more.
we've delivered them to a surface that we know is hostile and deadly
right.
to organisms on this planet. So yeah, could there still be something eking out under some solar panel piece on some Russian probe? Maybe. I think it's unlikely, but still.
That's the thing, as Jim says, the surface of Mars, we've come to believe, is pretty sterile.
Yeah.
It's bombarded by radiation and so on, and so any little droppings of things off of our probes, or even when people go there, is probably not going to survive.
That's right. And this is kind of sad to me, and something that we talk about in classes that I've taught, that the most likely kind of organisms anywhere in the universe, based on our current human knowledge, are single cellular organisms underneath the surface, where it's very hard for us to find them.
It's true on this planet.
Yeah,
right?
true on this planet too.
Yeah. So I think the ethics probably, we've got a lot to learn from what's going on at Lake Vostok, right? They're drilling deep into a pristine environment. How are we going to contaminate that environment? Same ethical and technical questions for drilling deep on Mars.
Right. All right. I have one last idea for you to respond to, just to maybe 30 seconds each. And it's something that that our colleague Steve Ruff said to me once. He said to me, there's literally nothing you could do to the Earth that would make it less habitable than Mars. The Earth will always be a better planet to live on than Mars. What are your thoughts, Jeff? True or not true?
Up to now, the Earth has shown a remarkable ability to support life. On the other hand, let's look at Venus, which has had a runaway greenhouse effect. Why? Venus should have been much more similar to the Earth, and we really don't understand it. There's going to be a lot more probes to Venus over the next few years, and maybe we'll be able to answer that. Is there any guarantee that some, we could reach a tipping point someplace and have a runaway greenhouse effect here on Earth? We don't know.
Yeah, Venus could be worse. What do you think?
We can ignore.
True.
I completely agree. However, it's a very, very Terra-centric perspective. It's certainly not going to be true for the Martians, right?
Yeah, it's not going to happen there.
For the Martians, that will be their home, their gravity, their habitability conditions, locally, maybe globally eventually, but certainly true for those of us.
Just true for us humans.
Yeah.
Well, let me thank you both so much, Jeff Hoffman and Jim Bell, for joining us for this conversation today. It was a tremendous fun for me, and I hope for you too. And for everyone who's come and participated, you will get links to the recording so that you can review in perpetuity all the things that have been discussed about Mars terraforming. So we're looking at the next couple of days, it's maybe hundreds of years before we can. Well, then, thank you all so very, very much, Jim and Jeff, and we will see you at our next Why We Go.
Thanks for all the questions, everybody.